All right, here we go. So we just wrote down 3 versions of the law of cosines. So if you look at this last one, just the first part, a squared plus b squared equals c squared, looks a lot like the Pythagorean theorem. But there's this extra little piece, and that's there because these are not right triangles. So there's a reason why all of this is here. If we worked it out and changed all of your oblique triangles, everything that's not a right triangle, into right triangles, you'd have these different pieces, and that's how this is going to work. So we use these if they give you a side and a side with an angle in between, or if they give you 3 sides and no angles, and we're going to go through both types of scenarios. So in this it says find the length of AB. So AB is across from angle C, so I'm going to think of that as being side little c, which is the way that these are noted in the formulas. Okay? So if I'm looking for this side, and I have the angle across from it and these 2 sides that are next to it, the formula is pretty straightforward. We would just have c squared equals, it's a squared plus b squared, so we'd have 19 squared plus 25 squared minus 2 is just part of the formula, times 19 times 25 cosine of 72 degrees. So all of this is just from this last version of the formula, a squared plus b squared minus 2ab cosine c. So it's the 2 sides and the angle in between that go in. So you want to be really careful about how you're doing this. On these, actually, you could, in theory, type it all in all the way across. If you do that, you're going to get c squared is approximately equal to 692.43 something, something, something. But you could, in theory, type it all in for these problems. There's only a couple of them you can do it that way, and then I'll talk you through the rest. So to solve for c, we would square root. So c would be the square root of whatever that number is that's on your calculator, and that is approximately 26.3 if we round to the nearest tenth, which is what it says in the directions. And these are in inches, so this is inches. So these are the easiest kind of problems to use the law of cosines for. So we'll do a couple that are fairly straightforward. Then we'll do some where you have to use the law of cosines and the law of sines a little bit, although it doesn't have the really hard part of the law of sines. And then we'll do some that look a little bit more bizarre with 3 sides. So there's 2 of each. All right, so if we go to question number 2, it says find BC, which is over here. That's like little a. Shh. It's recording everything you say. So since we're looking for a, I'm going to use the a squared formula. So we're going to have a squared equals, and it goes b squared plus c squared. So that's just these 2 sides, 11 squared plus 25 squared minus 2 times 11 times 25, and then cosine of 124 degrees. So in theory, you can type all of this in. Just be really careful. Look back through it after you type it in. Or you can do it in pieces and then add if you think that's easier. If you do all of this math, you end up with 1053.556, blah, blah, blah. There's a few decimals. And so the answer, we're just going to square root both sides. So a would be about whatever the square root of this is, that number on your calculator. And so a, if we round to the nearest tenth, comes out approximately 32.5. Since these are all measured in kilometers, that would be kilometers. Make sure that your answer makes sense. 1053 is what a lot of people would put on this because they forget to square root. If you've got 11 and 25, that would be pretty big for the third side. Make sure that it fits common sense. Okay, so those were the most straightforward problems where you have everything you need, just put it in, you're good to go. Okay, when we start solving for angles, it gets a little bit trickier, but I'll talk you through it, it'll be fine. So it says find the measure of angle C. Well, since I have angle B, I actually have to solve for side B first. So since we have angle B, must find side B first. And I'll point out at this point, we could not use the law of sines directly to find this because I don't have any angle and side pairs to set up a proportion. So we'll just solve for what we can solve for. If they gave us angle B and the two sides on each thing, we'll find that. And then we can go back to use a little bit of law of sines, but it's not the really complicated ones. It'll be fine. Okay, so when we do this, we're going to use the b squared version of the formula. So b squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of 95 degrees. That says cosine even though it looked really weird. Let me try that again. Looks like WS. I don't know what I'm doing. There we go. Cosine of 95. So we'll start. We'll just type all of that in. So b squared is 224.7339. I don't know why I keep adding decimal points every time, but that's fine. So you find b by taking the square root of that number, and you get approximately 14.99. So about 15. You probably don't want to round it off too much at this point, but it's pretty close to 15. Okay, so what I'm going to do is on my picture, I'm going to write that in. This side is now 14.99-ish. And then what we want is angle C. So I said we weren't going to use law of sines. I guess I lied, but this is not a really complicated one. So we're going to set up a proportion. So we have 95 with this. So that can be one side of our proportion. So if law of sines would be sine 95 degrees over 14.99 equals, and then I have this side and I'm looking for this angle, so I'd make it equal to sine of angle C over 12. So we cross multiply, you get 12 times sine of 95 degrees equals 14.99 times sine of C. And then how do I get sine of C by itself? Divide by 14.99, just making sure you guys are awake. You are. And so if I type all of that in, I get about 0.797 equal to sine of C. So to get the angle, we're going to do inverse sine of that number. If you just keep it on your calculator and use that answer feature, it comes out about 52.8 degrees.
So 53.
Well, they said to round to the nearest tenth, so we're going to go ahead and leave a tenth on there. And this is always one of those lessons I feel like I should talk about significant digits all the way through, which I know a lot of you have already done in physics. So I'm not sure, based on what I've seen on my answer keys, that they're always following the rules for significant digits. So what I do with these is if your decimal is off just a tiny bit, I usually count it right if I can see all of your work. So I don't want you guys to stress about that, but for some reason the math stuff, they don't always follow the rules that they teach you in science, which is frustrating, but just is. Well, they say to round to the tenths, so we're just going to round the final answer to the tenths. What I usually do is keep more decimals in that till the last step, and that usually gets what's on the answer key. That's not technically how it's supposed to work, so it is a little frustrating, but it's just how it is. My main point here is to make sure that we can get it close. If you're working for NASA and you're launching rockets, then you definitely want to pay more attention to how you're rounding everything off.
You definitely overestimate us.
Okay. So we're going to do another one like this. So I have these in pairs. So it says, again, find measure of angle C. I can't. So we're going to find the side that's across from this. So whatever, if they give you a side angle side situation, where the two sides and the angle's in between, but we're not solving for the angle, we're not solving for a side, we're solving for a different angle, you're still going to set it up by solving for the side. I'm not talking very well. So we will have b squared equals 26 squared plus 13 squared minus 2 times 26 times 13 cosine of 124 degrees. So again, like I said, you can type all of that into the calculator at one time if you want, or you can break it up into pieces. We get 1223.01, and you could keep more decimals than that if you want. When we square root that, so b is the square root of whatever that is, then we end up with approximately, I'm going to keep a couple decimal points, 34.97. So really close to 35. Whether we can actually round to 35, I don't know if it comes out right if we do or not. So we'll just leave it like that for now. And then they want us to find angle C. Now that we found that side is 34.97, I can set up the law of sines. The law of sines, you have to have an angle and a side that's across from each other. So I'd have sine of 124 degrees over 34.97 equals, and then we're solving for C. So we find C, and you want to make sure you're using the side that's across from C. I don't want to use the 26, that would find A. I want to make sure that I'm using the other. And so if I do that, then I'd have sine of C over, I have a hair, sorry, over 13. And we cross multiply there, so we get 13 times the sine of 124 degrees equals 34.97 times sine of C. Divide here. And we end up with about 309, I can't talk, 3079 is sine of C. So then we have to do inverse sine.
You're off the page.
And I'm kind of running into the next problem. I'll cover that part up. So inverse sine of 0.3079 comes out about 17.9 degrees. Okay, so
No more.
there is a little bit of law of sines. The last two are different, so I've got to do them because there's 3 different cases. So basically you set up law of cosines and then do what we did in the last lesson. Because they're giving you side angle side, you do not have to check for the ambiguous case. We are guaranteed that this is the only angle that can occur. You don't have to check for extra triangles or angles. Nothing funny is going to happen with that. Okay? When we get down to 5 and 6, there is a little bit of a special thing that we have to do. Okay, so we have 3 sides. This is what we would call a side-side-side situation. We're proving triangles congruent. If we have 3 sides, we can guarantee what the angles are going to be. They will always come up the same. We're looking, it says find measure of angle B. There's a rule that you have to find the largest angle first. Even if it's not the one that they want, you may want to put a colored box around that. If you don't do this, about half the time, you will get the wrong answer. And it has to do with a little bit of strange things happening. You have to find the largest angle first.
What a connection.
So the largest angle is always across from the largest side. So the largest side is 28. Angle B is the largest angle, so we're good. Okay? So this would be side B that's across from B. This is side C. That's side A. When we're solving for angle B, you want to use the equation that has angle B in it, which is the one that starts with B squared. So we have B squared equals A squared plus C squared, so 25 squared plus 27 squared minus 2 times 25 times 27 cosine of angle capital B. This is what we're solving for, so this one is going to look a little different. You have to pay attention or you will mess this up. I'm just saying, people are like, yeah, I got this every year, and then they wonder why they miss half their problems. This is why. Okay, so this one you cannot type all into the calculator because you're solving for this. So you want to do this part all together and all of this together. So you do the 25 squared and the 27 squared and add those up. Oh, and I'm sorry, B squared we already have. So B squared, I should be putting 28 squared in. So let's do that really quick because I have that. So instead of, okay, I changed it up here, and then I want to actually do it down here. So 28 squared is 784. 25 squared plus 27 squared, I just would put all of that in and get 1354. And then it's minus 1350 if I multiply 2 and 25 and 27 together, cosine B. So pretend this is just an x for a second. we have to treat these as two separate terms. They're separated by a minus sign. So first you want to get the part with cosine B in it by itself, which means we need to eliminate the 1354. So subtract that off of both sides. And we get a negative. That's okay. It'll cancel out in a little bit. So you get negative 570. And over here we have negative 1350 cosine B. What would we do next? Divide by negative 1350. So that cancels, and we're going to get a decimal. So it's about 0.42 something 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 equals cosine B. I would keep more decimals than that on my calculator. And then you'll do inverse cosine of that number. And you get about 65.0 degrees for angle B. And so that one is actually done. So, yes. So it was okay to do all of this like this. We didn't have to do any extra solving because angle B happens to be, this just happens to be the largest angle because it's across from the largest side. You won't always have that. So on 6, we're actually going to need more room than we have. So let's do this. I don't know if you guys can peel this up, but I'm going to cut off problem 6 and put it on the top of the practice page. And we're doing this on the video. It's okay. It's all good. But I want to make sure that we have room not to get confused. I used up too much room on number 4. I wasn't planning my space very well. So I'm going to go over to our other page of notes that we'll use for practice in a second and glue that on there, and we'll do this one next. Okay, guys, we're recording right now. So we're going to do this quickly and quietly. Thanks. All right. So here's number 6. So remember that we have to, when we have the 3 sides and no angles, you want to solve for the largest angle first. So I'm just writing that in. There we go. I'm on the screen. So they want us to solve for angle B, but before I set that up, angle B is actually the smallest angle because it's across from the 22, which is the smallest side. So I cannot go directly for that. About half the time it works, and about half the time you'll get the wrong answer. You want to find the biggest angle first, just to make sure there's no ambiguity in what we're doing. So which of these would be the largest angle? So the 29's here, and so C is going to be the largest angle. It will be across from the largest side. So this would be the largest angle because it's across from the largest side. So we're going to set up to solve for C. So our formula, since we had to turn the page, was C squared equals A squared plus B squared minus 2AB cosine C. So that's what I'm going to use. This would be little c, this would be little a, this would be little b, just going across from the angles. And so we're going to solve for angle C first. So I have little c is 29.6. We're going to square that. And then we're going to have 22.4 squared and 28.2 squared. It doesn't matter if you mix up a and b. And then minus 2 times 22.4 times 28.2. I'm going to spread out my notebook so I can write right here, times cosine of angle C. I just didn't want to write half on this and half on the notebook, sorry. So I would do this squared. 29.6 squared comes out 876.16. And then I would put these two together next, and that comes out 1297. And then I would do all of this together, which comes out, so negative 2 times 22.4 times 28.2, and it comes out minus 1263.36 cosine of C. Okay, so we've got it all set up. Now you guys help me. How do we solve for the cosine of C? What will we do next?
Subtract
subtract the 1297, so subtract the 1297. And so if we subtract the 1297, we get negative 420.84. And then over here we still have negative 1263.36 cosine of angle C. And then to get cosine C by itself, we divide and so we get this decimal that's 0.333, kind of looks like a third, equals cosine of C. We'll do inverse cosine of that number, whatever it is, really close to 1/3, and we get approximately 70.5 degrees, and that's angle C. So we have to remember what we're solving for. So this is 70.5 degrees. I'm going to put it up there on the picture. And then they want us to solve for angle B now so we can set up the law of sines. So the 70.5 we just found would go with this, and that can be the first half of our proportion. I'll do that over here. So sine of 70.5 over 29.6. And then we want to solve for angle B, which is here. So I'm going to have sine of B over which side? Which side goes with B?
22.4.
The 22.4. Good. You guys are smart. I'm just making sure. Which is across from it. And we're going to cross multiply. So we would have 22.4 times sine of 70.5 equals 29.6 times sine of B. I'm going to try to draw a line there so it doesn't get confusing. And then we solve for the sine of B, so divide by the 29.6, and we put all of this into the calculator. 22.4 times sine of 70.5 divided by 29.6, and we get 0.713 equals sine of B. Yeah, I have to scoot that up. This is what we got when we put it in the calculator. And then we'll do the inverse sine of that number. We end up with about, rounding it off, 45.5 degrees. So that's the final. Oh, I meant to write inverse sine. Good, got the negative one. We did it.